IQ seems to be growing, right? Generation by generation, the level of IQ seems to be growing. How should we look at that? Because I'm not sure, because the kind of tests that we use, they never tell us whether we use norms, but we don't know when they have been updated, in what kind of languages, what countries. I don't imagine they're redone every generation. So how should we look at that? How should we interpret that? Where I left it was, I think 100 was the average score, 85 was the minimum. This was Ravens to get into the US Army. How should I look at that now if I have a Ravens in front of me?
Okay, so first, it's a phenomenon called the Flynn Effect by someone called James Flynn, who first discovered it. And it was actually, you mentioned Murray. It was Murray who named it Flynn Effect, which is interesting because Jim Flynn is a devoted environmentalist. So he is one who has been the fiercest opponent of the hereditarian community, sort of, in the last few decades. And basically, he's interested in this IQ gains because he uses them as a demonstration that something environmental must take place, because these IQ changes are large scale and no corresponding genetic change has taken place. As for the okay, so that's one thing. Second, it's not ever continuing. Unfortunately, it seems to have stopped. So most recent data shows that it probably has stopped in many industrialized countries that we have data on, but it did go on for 100 years or so. Now, as for the actual numbers, 185, how does that go? I try not to be technical, but in order to understand this and how to use this actually in applications, because it's not only HR, this affects the death penalty. There are books on this. Because for someone to, anyway, so I get there.
Yes.
So the way IQ tests are normed is that you administer a test with a large population, and then the mean score will be worth 100 IQ. So that's the concept called deviation IQ. It's actually invented by Wexler. So you compare someone's raw score on a test with the raw score distribution of a population, and that's called the norming population, the sample to which everyone is compared. Now, if somebody gets a score that's the population mean, so somebody performs at the same level of people on average, will get an IQ of 100. This is usually age standardized, so people are compared to their peers rather than people of different age groups. And if you perform at the same level as the average of your peers, your IQ will be 100. And then every standard deviation is worth 15 IQ points.
Okay.
So if you perform one standard deviation above the mean, it will be 115, two standard deviation. Now, since this follows a normal distribution, or to be more precise, we presume it does, or we massage our test results until they do for normal distribution. Because the normal distribution has very nice properties, we can convert these to percentiles, which means that we know how rare that performance is. If someone performs on average, they will get an IQ of 100 and also a percentile of 50, because it's the mean and the normal distribution is symmetrical, so exactly as many people are below the mean as above the mean. Statistically speaking, you would say that the mean equals the median, because there is an equal number of people above and below the mean. So that's for the mean. If you perform one standard deviation, you know that you've performed better than 80 for about 84% of people. If you perform two standard deviations, then you will say you performed at the 98th percentile. So you outperform 98 out of 100 people, and so on. And that's the way to standardize a test. So then you get an IQ score, which can be converted to percentile scores. It's just a side note. Personally, I prefer percentiles a lot. IQ is something that's very very, very often misunderstood, and it's very, and then it's all over the the tabloid media, I'm not going to say names, but there's no month that passes without one or two famous actors finding out that they have an IQ of 195, or somebody finding 2-year-old who's already
True.
smarter than Einstein. I love those. I love those headlines. It's only 22-month-old and already smarter than Einstein. I mean, but what can they probably even mean by smart in that context? Anyway,
Yes.
so I think percentiles are much better, and in my practice, I also find it's much easier. People are fascinated by IQ scores, but they cannot really interpret that. I mean, it's hard. How is 140 a lot? Is 160 a lot? I mean, whereas if you say that, okay, your IQ is higher than 97 out of
97
100
people.
people, that
Yes.
everybody understands. So that's percentiles IQs. They're always convertible in normal distribution.
I think that works well with the index as well, right? With the indices, because
Yeah,
it gives you pretty much a ranking.
yeah.
In 100,
But
you are the
it's
90%.
compatible with to be frank. I'm pro index, as you know, but it's compatible with the G approach as well. I mean,
Yeah.
you can index people. I mean, if you measure someone's height, you don't need to have a deviation kind of score, because that has an absolute. That's very different from IQ actually, because that's an absolute score, someone's height, and the reason that's an absolute score is you have an absolute zero. With IQ, they don't have that, an absolute zero, and so you can only use this as a relative index rather than an absolute one. But if you could represent height at a normal distribution and convert it to percentiles, even though it's a very real thing, it's not an index. Someone's height is still, you can say, if you're taller than 97 out of 100 people, then your percentile score for height is 97.
97.
Even though you can also express it in centimeters. Okay, so that's compatible with both. So that's how you norm tests. You give them to a large sample of people, and they calculate the mean and the standard deviation in order to translate them to percentiles and or IQ scores. Now, if you keep repeating that, you might find that these means have shifted, and that's the Flynn effect. So it means that the mean score of a population has shifted from, let's say, 42 out of 60 to 44 out of 60, which means that in this new standardization, you will need to have a 44 out of 60 to have an IQ of 100.
100, exactly.
And that's so you don't have to. Every new norm is a new norm, and the mean will always be 100. It's not. It won't change. But if you want to express the magnitude of the change, or the magnitude of the Flynn effect, as they say, what you can do is you can compare the new mean to the old norm.
Yes.
So if you
and then you will see the increase in population.
Exactly. So you get, now the mean is 44, and the previous standardization was 42. You look at the old norms, how many people you would have outperformed with that score 44 in the previous standardization, and you translate that to an IQ, and you find that with 44 you would have had an IQ of 106 in the old norm, and then you can say the extent of the change is 6 IQ points over the period of time that actually elapsed between the two standardizations. So if it was, let's say, 12 years, then you say it's 6 IQ points over 12 years, which means half an IQ point for every year. Basically, that's what you do. And there are two side notes, and then I'll stop. One is that this effect is much stronger on fluid than on crystallized tests.
Okay.
So the increase is much stronger on fluid than crystallized tests. It's strongest on fluid and weakest on crystallized.